Here's the graph of the original function, this red curve from 0 to 2 pi. You're asked to find relative maximums and minimums, absolute maximums and minimums, and points of inflection. This blue graph with the dashed lines is actually the graph of the first derivative. You can see that equals 0 at 4 pi over 3 and 5 pi over 3. And this green graph is the graph of the second derivative, and it equals 0 at, I don't have this labeled, this is pi over 2 comma 0. And at 3 pi over 2 comma 0, which is right here. Okay, so how do you do this? Here's f of x. To apply the first derivative test to determine relative maximums and minimums, the derivative of this term is radical 3. The derivative of this term is plus 2 sine of x. When does that equal 0? When x equals any angle that has a sine of negative radical 3 over 2. An angle that has a sine of negative radical 3 over 2 is 60 degrees, or pi over 3 radians, and sine is negative in the third and fourth quadrants. So we want to go pi over 3 past pi. That gives us the 4 pi over 3. Or we do this red angle, which is 2 pi take away pi over 3, which is 5 pi over 3. Those are the critical numbers where the first derivative equals 0. There are no places where the first derivative is undefined. So if we draw a little first derivative test number line and put on the critical numbers, 4 pi over 3 and 5 pi over 3, the sign of the derivative in each of these intervals will tell you whether the original function is increasing or decreasing. So for example, f of pi is equal to radical 3, which is positive. That's supposed to be a plus sign. That tells us the original function is increasing. Between 4 pi over 3 and 5 pi over 3, for example, 3 pi over 2, f prime of 3 pi over 2 is negative, because you'll have 1.7 take away 2, because this will be a minus 2 at 3 pi over 2. Negative, so decreasing in that interval. And then to the right of 5 pi over 3, the original function, or the first derivative is positive, original function is increasing. So we've got a max at 4 pi over 3 and a min at 5 pi over 3. And that's what we see right here. In other words, these tangent lines are horizontal right there. To find the absolute maximums and minimums on that closed interval, you have to evaluate f of 0, f of 2 pi, those are the endpoints, and f of each critical number. And you can see this from the graph that the relative minimum is 0, negative 2, and you put 0 into the original function, yeah, you get negative 2. And f of 4 pi over 3, you could get an exact value by putting 4 pi over 3 into this function for x. But there's a decimal approximation, decimal approximation, decimal approximation. So the absolute max is at 2 pi, the absolute minimum is at 0. And points of inflection, the second derivative is 2 cosine of x. That equals 0 when x is pi over 2 or 3 pi over 2. So to apply the second derivative test, you'd put those hypercritical numbers, pi over 2, 3 pi over 2, on a number line. Here's the 2 pi and the 0. Pick number, so the sign of f double prime in each interval will tell you what f is. So f double prime of pi over 3, for example, well, we see it's concave. It looks like it's concave up here. So this is f double prime is positive, smiley face, concave up. At this point, pi over 2, the sign of the second derivative changes to negative, concave down. So that's a point of inflection at pi over 2. That's what this is right here. And similarly, this will be positive. And at this point right here, changes to concave up. That's 3 pi over 2, comma 8.1621. There you go. Hope that helped. If you have any questions, post a comment.